Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, let's thank to Allah Subhanahu wa Ta'ala who has been giving and some mercies and blessing to us so that we can attend this meeting without any troubles at all. Secondly, may salawat and salam be with our Prophet Muhammad SAW, who has guided us from the darkness to the lightness in the world. Now, let's introduce myself. Hello, my name is Kamilia Nadifa Zahra. You can call me Diva. And I study at Maulana Malik Ibrahim State Islamic University Malang in the Faculty of Science and Technology in the Department of Chemistry in the Chemistry Class of C. Here I will explain about my summary. My first summary is sampling and preservation strategies. Sampling is the collection of a certain volume of a water body to be studied with the smallest possible amount, but still representative and still has all the same characteristics as the water body. Sampling or taking samples can be divided into three steps, namely, number 1, representative sampling, number 2, transport and preservation of samples, and number 3, chemical analysis of samples. The bottle or sample container that will be used to take the sample must be clean and has been rinsed with distilled water and then rinsed again with the liquid that will be used to fill the water and dry. Sampling tools such as pipes, pumps, etc. must be clean and free of residue from previous samples or mold and mildew growth. The tools used must not be contaminated by metal or sampling equipment that can dissolve in the sample. Tools that can cause contamination and wet sands are iron, brass, bronze, etc. because it is soluble in acidic or basic solution. And don't use sample containers made of plastic and rubber, because both are soluble in solution or water containing organic solvents or oil and gasoline. The sampling process must be taken separately using anti-contamination materials. For example, a bucket, plastic bottle, or glass tied with a rope. Then put it in the sampling area. The process of taking samples at a certain depth can be done by 1. Using a bottle or container that can open the cap at the desired depth. Number 2, can also use a clean suction pump or hose. 3. If the sample comes from tap water, it can be taken with an open beaker or bottle that can be closed depending on analysis plan. Automatic sampler is a special tool for consecutive sampling. For example, suction pipe, pump, hours, and isothermic box. Isothermic box is which contains bottles of mixed samples by cooling. A common way of preserving samples is a cold atmosphere. The sample is transported in an isothermic box containing ordinary ice or dry ice. Disturbance that may arise during the storage and transportation of samples such as oxygen and carbon dioxide gases that can be absorbed by the sample water or can be removed from the sample water into the air and suspended and colloidal substance that can form their own flux and settle so that there are samples that are different from the condition when they were taken. Then, like substance and liquids can float on the surface, and there are some solids that can be oxidized by dissolved oxygen so that they turn into other compounds. My second summary is contamination and loss in water analysis. Contamination is the entry of unwanted compounds into the sample during the sample pre-treatment process or during analysis. Source of contamination in samples can be from the atmosphere, apparatus, water equipment, and reagents. Number one, contamination from the atmosphere. Derived from particulate trace elements on the soil surface and materials suspended in the atmosphere. The simplest way to avoid atmospheric contamination of the sample is to cover the sample solution during the preparation and analysis process. Number two, contamination from apparatus. The analysis can be a source of contamination in the sample to be analyzed either through direct contact or through the air, such as dust and cigarette smoke, which can provide contaminants in the analytes in the form of powder, lotion, perfume, apparatus, etc. And what can reduce contamination is the use of masks, gloves, laboratory coats, etc. Number three, contamination from equipment. Glass in analytical chemistry means borosilicate glass such as pyrites unless specifically stated. Contamination of the sample from the glass is usually caused by attack or dissolution of the container by the solution. How to anticipate contamination from containers? For example, by washing the equipment using a one-to-one mixture of H2SO4 concentrate and HNO3. Other preparation equipment that is often used and has a low probability of metal contamination. 1. Fused silica or quartz. 2. Plastic or polyethylene and polypropylene. 3. Teflon tetrafluoroethylene polymer. 4. PVC polyphenyl chloride. Number 5. Rubber. And number 6. Filter paper. Number 4. Contamination from water. Since water is used in very large quantities compared to the reagents, it is necessary to pay special attention to the purity of the water used, especially in trace analysis. To reduce metal and water contamination, the water needs to be passed first into the ion exchange resin column, or at least 2 distillations are carried out. Number 5. Contamination from water can be grouped into mineral acids and ammonia, inorganic solids, organic reagents, and organic solvents. My third summary is contamination from reagents. Contamination from reagents can be grouped into 1. Mineral acid and ammonia, 2. Inorganic solids, 3. Organic reagents, and 4. Organic solvents. Number 1. Mineral acids and ammonia. Most mineral acids contain certain amounts of metals. Extra pure acid contains metals in very low levels. Ultra pure generally contains a fairly low metal concentration, but the content of some elements varies from one product to another. Analytical reagent-grade acids generally contain metals as listed in the table. Ammonia is this solution when in the water is placed in a glass bottle, which will later be contaminated by silica, aluminum, calcium, and other elements that may be caused by the attack of alkaline solution on the glass. Analytical reagent ammonia can contain heavy metals in very low concentration. This may be due to the absorption of these metals by glass. 2. Organic solids. In organic solids, with reagent quality generally pure enough to be used directly without purification. Usually used as a blank solution for solution control. Tin or Pb is an important metal. It contains KCl in ACl in NH4NO3 and KNO3. Analytical reagent range from 0.1 until 0.3 ppm. Purification is generally by means of crystallization and filtration. Number 3, organic reagents. This metal is usually derived from solvents or reagents used in the synthesis of ligands. Usually used in small quantities so that contamination can often be neglected. By caution is necessary. For example, when using reagents as blinds. Number 4, organic solvents. The content in it is relatively low. What you have to watch out for is the presence of other organic compounds dissolved in the solvent because it will usually interfere with the spectrometric determination. For example, CCl4 and CHCl3, if left unhacked, will produce COCl2 oxidation results, which will interfere with the determination of metals by the Titizen method. Loss of analytes. During the preparation, separation, and determination stage, the analyte may be lost from the sample's solution by the following factors. Factors 1, adsorption, factor 2, volatilization, and factor 3, co-precipitation or settling. Thank you. Now I would like to finish up by saying thank you for your time and your attention. I would like to thank you all for taking time to listen to my presentation. I hope what I have shared will be beneficial for all of us. That is all from me. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.